Good morning, everybody. Not too bad for 9 o'clock in the morning in Barcelona. Actually, I just got back from dinner. I'm adjusting to the Spanish time of having dinner late, and I don't know who schedules sessions at 9 o'clock in the morning when you're just getting back from dinner. But in any case, welcome to the case of the Unexplained. My name is Russinovich. And before I actually get started in the case of the troubleshooting, I'll just briefly mention who I am. My background, I work at Microsoft. I've worked there for a little over a year. Previous to Microsoft, I ran a software company called Winternal Software and a freeware website called sysinternals. And it's no coincidence that this talk is going to present a number of the sysinternals tools used to troubleshoot real-world problems. And so I'll introduce the sysinternal site and tell you a little bit about what's going on with sysinternals in a few minutes after I motivate this session. So you probably came to this session because you've had a number of incidents over time where either your machine or machines that you manage or your friends' machines or your family's machines have problems. And those problems come in many different shapes and sizes on Windows. Some of the problems you might experience are just sluggish performance. So you're using the computer and you notice that it's not as responsive as it should be or as you expect it to be. And those conditions can be temporary or long-lived. They can be intermittent. And wouldn't it be nice to know really what's going on so that you could address the problem, make your system perform as well as it should? One of the myths of Windows is that it slows down over time. Well, it really doesn't slow down for no good reason. It's not the buildup of cruft that slows it down. It's actually apps that you install that stick themselves in auto-start locations that slow things down. And it would be useful to be able to go and identify the actual root causes of that mysterious kind of slowdown that people believe happens. Also, a lot of times, just as you're using applications or Windows itself, you'll get error messages that are bizarre, kind of undecipherable messages. How many people have seen hexadecimal error codes come out of message boxes? And we've all seen that, unfortunately. I'm trying to get rid of those from Windows. I'm on a kick to try to clean that up in the next versions of Windows. But those come from third-party applications as well. And one of the problems with error messages is they don't often reflect the root cause of the problem that results in the error message. So the error message leads you down one path or maybe down no path, and the underlying root cause can be something like a locked missing file, a permissions problem, something that's corrupt. And how many people still experience the occasional hard system hang or blue screen on Windows machines? So quite a few of us do that as well there. And so the purpose of this session is to show you that with just a few little tools and spending a few minutes, you can solve a vast majority of these types of problems very quickly and easily. I'm going to teach you as we go along how to interpret process thread and file system activity and registry activity, how to monitor what's going on, and how to dig in and find a root cause for some of these errors and sluggish performance issues, how to interpret thread call stacks, because sometimes you need to dig in to find a root cause by looking at the stack of a thread, how to analyze crash dumps. I'm going to do all of that in about 75 minutes. And along the way, I've collected a bunch of real-world cases. And some of you that have read my blog know that every now and then I'll publish one of those and how I go step by step solving some of these cases. When I sat down to put together this talk, I went and got together all of the different cases that I'd gathered over time. And and I just threw it all in one big slide presentation. And I ended up with a talk that was 100 slides long. That's how many real-world case studies I've had. So it was really, really painful for me to narrow it down to just what would fit in 75 minutes. I basically had to go through and just pick one or two examples that highlight a particular troubleshooting method or tool and stop there without getting into all the really cool kinds of troubleshooting scenarios that I'd come across over time. So, what's that? I just got a Windows security alert, apparently. My system is infected with malware. Visit malware.com to get a free spyware cleaner. Well, I don't know where that came from, but let's just set that aside. And we'll go figure out who's telling us that in a minute as we go along. Now, one of the criteria for the case studies that I'm going to include here is that they're all real. They're all either ones that I've encountered myself. Some of these actually I've encountered within the last week. One of them on the plane ride over here I've included in this session, or from friends or family members. And one of the key takeaways of this is that even if you can't fix the root cause. When you identify the problem, you might, at least by understanding what's causing the problem, figure out a workaround. And so it's not always the case that you can solve them. Sometimes it's just a workaround, or just knowing what the root cause is as good as we can get. But some of the tools that we're going to use are from sysinternals. Like I mentioned, sysinternals is a freeware site that I started with Bryce Cogswell back in 1996, and now it's part of Microsoft. It's actually now been renamed the Microsoft Windows Sysinternals TechNet Resource Center, and this is a live screenshot of it, a live picture of it. Oh, actually, you haven't been seeing anything I've been talking about. How do I switch? Do I have to do it? I don't. Or do they do it? Hello? Is anybody listening? They told me I was good. I'm going to just start pressing buttons unless somebody comes down here. Here we go. In any case, a bunch of people always ask me what's going on with sysinternals. But sysinternals is still basically just me and Bryce, and we still continue to update the tools. Thanks. I wish I could claim credit for troubleshooting that case right there, but. So Bryce and I still continue to update the tools. If you've been following along, and actually if you look down here at the what's new, just in the last couple weeks, we released a brand new tool called AD Insight. It's an Active Directory client-side monitor, watches LDAP traffic coming from client-side programs. And you can see a Process Explorer update within the last month. So we're still actively maintaining and updating these tools. And they're all free. There's no WGA check for those people that were afraid of that happening. You can just go simply download them the way you used to. And in fact, you can download them, all the tools, in one big zip file. Another tool that I'm going to be using is something called WinDebug. It's part of the Debugging Tools for Windows package, and that package is available for a free download from Microsoft here at the Debugging Tools for Windows webpage. Just search for Debugging Tools on Microsoft.com, and you'll come across this page and be able to download it. And then finally, I'm going to show a tool called KernRate. KernRate is a kernel mode sample profiling tool, and that tool used to be part of the resource kit. It's now available for download on this web page. Just search for KernRate on Microsoft.com. You'll come to this page. It doesn't say that it supports Vista or Server 2008, but in fact it does work on Vista and Server 2008, and a version will be released shortly that officially supports those two operating systems. So those are the sites where you can go download the tools that I'm going to be showing. One of the tools, by the way, that I'm going to be using extensively to zoom in on the screen and annotate things is called Zoom It, and that's also a sysinternals tool that you can get for free. All right, so I've divided the types of problems that we're going to look at into a few different categories, starting with sluggish performance. Then we'll take a look at application hangs. Then error messages, bizarre error message, how do you troubleshoot the root cause of those? Unknown images, which doesn't really sound like a troubleshooting kind of case, but when you're looking at your system and you see things that you don't expect to be there, and when they don't identify themselves clearly, that's at least that concerns me, and I always want to go figure out what the heck this thing is doing on my box and where it came from. So we'll give you some tips on how to identify those things. And then I'll wrap up with how you troubleshoot blue screens and hangs, if you ever have those. And I'm going to introduce the tools as we go along. As we come across troubleshooting scenarios that require the use of the tool, the first tool I'm going to introduce is called Process Explorer. How many people have used Process Explorer? So almost everybody has used it, and you're familiar with the basic operations. For those of you that maybe have never seen it, this is Process Explorer. It presents a view that's similar to Task Manager, but with a lot more information readily available. One of the first differences you'll notice is that it's got this tree indentation. That's the parent-child relationship of these processes. So WinInit, for example, here is a parent of the service process directly beneath it. Also, the colorations are different. Instead of just all white, you see some pink processes, you see some blue processes and white ones. The pink processes are hosting Windows services. The blue processes are running in the same account as Process Explorer. So I'm running Process Explorer in my account, so those blue processes are all my processes, part of my login session. And finally, the white ones are system processes or processes running in other user accounts. And those include things like the system process itself, CSRSS, WinInit, and so on. You can also see descriptive information. This isn't coming from a database. This is coming from the applications themselves. In their version resource, they can put in a description and a company name, and it's good practice to put that in so that when you're using a tool like this, you can see exactly what this process is coming from. One of the really cool features, I think, of Process Explorer is it makes it very easy for you to identify activity on your machine. And one of the things that I always do when I launch Process Explorer is I first of all make it an auto start. On Windows Vista, I make it run as admin, and I launch it as admin, and then I use these options here. I always check hide when minimize, allow only one instance, and make sure that CPU tray, history tray is in the tray icon, and then I have it running all the time there in the tray. It uses minimal resources when it's in the tray. And the nice thing about being in the tray is that you can easily identify system activity down here. And if you see a spike of red or green down here in that tray icon, you can hover the mouse and it'll tell you the biggest consumer of CPU at that point in time that you've hovered. So that's often the way that I identify sluggish performance, is maybe not directly feeling it. Sorry about that. Maybe not directly feeling it, but by noticing a spike in CPU down in the tray icon, knowing that that's affecting my performance, and then hovering the mouse to see what's causing it. Another way to look at information globally for the system is to look at the system information dialog in Process Explorer. And you can bring that up either from Process Explorer itself or by right-clicking and saying System Information. And this is a lot like the Performance tab in Task Manager, rather. And you get a bunch of information here: physical memory usage, statistics, CPU I/O, and handles, and so on. And then you've got three graphs: CPU usage, virtual memory usage, and I/O usage. And if you hover the mouse over the graph, you get a nice tooltip that will show you for that point in time the biggest consumer of CPU or the biggest consumer of I/O when you see an I/O spike. And we're going to take a look at that in a second, troubleshooting something that's going on my system right now. And that is those spikes that you saw up in the system information CPU graph. If you notice, there's a pattern here. There's a spike right here and a spike right there. And if I hover the mouse over these spikes, that spike right there, that spike right there, the tooltip over here says that that's the sidebar process consuming 50% of the CPU. And this spike right here is another spike from that same process, the sidebar. How many people are familiar with what the sidebar is? So the sidebar is this new process in Windows Vista. It sits over in the sidebar. Where are you, sidebar? Actually, I've got to click something open here to get this. Come on, sidebar, show up. It's never there when you want it. Actually, I've got to exit presentation mode. There it is. There's the sidebar as it's running on my system. I've got a few gadgets there configured. Now, that spike that I saw, if we go take a look at the sidebar process, or we'll go look at the process list and find sidebar, you'll see that there's two instances of sidebar. And I'm not sure which one of those is causing the spike. Actually, I could go look at the process ID. But the reason that there's two is that that child sidebar instance is hosting third-party gadgets, and the first one is hosting just the built-in Windows gadgets. Now, I see a spike in the sidebar there, but I don't know which gadget is responsible for the spike. All of those gadgets are hosted within the same process. Sidebar gadgets are just DHTML code. They can actually load in DLLs. So any one of those gadgets could be causing my spike. And the question is, which gadget is responsible for those periodic spikes that are spaced actually 5 minutes apart? So to understand which one's causing that spike now, we need to call upon another tool to maybe look inside of sidebar and see what's going on. See if there's some secondary activity that is connected with that CPU usage. And the tool we're going to use is Process Monitor. Process Monitor is a real-time file system registry and process monitoring tool. If you're familiar with FileMon or Regmon, it's those two tools, essentially the functionality of them combined in one tool. It's got a bunch of enhanced functionality over those original FileMon and Regmon tools. For example, it has more advanced filtering. Let's go ahead and launch Process Monitor. And it's starting to capture activity. So for one thing, it shows you tool tips that show you information about the process that you're hovering the mouse over. So this is Windows Explorer from Microsoft Corporation, shows you the path and shows you a bunch of columns. It looks a lot like FileMon, but you can configure the columns to show you a bunch of extra information, like additional application details that weren't available in FileMon, like the image path, the command line, the description of the image, version architecture, event details, time of day, the category, duration, and then down there at the bottom, things like what session, what terminal server session the process is in, what username it's associated with, the thread ID, the parent ID, and some Vista-related characteristics like its integrity level or whether it's virtualized. All of that information is also available when you double-click on a process or an event and go to the Process tab. So you can see all that, the path, the command line, the process ID, the architecture, and so on, as well as a list of loaded modules at that point in time. And I mentioned that one of the big advantages over FileMon is much more enhanced filtering. So this is the filtering dialog. If you really want to get advanced, you can combine different filters. Like you could say that you only want to see a particular event class, operations that have a particular image, have nice operators like is less than, is more than, excludes, contains, begins with, and so on. And for columns, for attributes that have actual data that's already been collected in a trace, it pre-populates the dropdown. So if I say process name, I want to filter, and I just want to see sidebar.exe, I could just simply select sidebar.exe right there, which I'll do, and then say include or exclude. I'm going to include this one, say add, and press OK. That updates the filter, and there we have sidebar activity that we've captured just as we were talking there, and we were running a process monitor. Now the question is, which gadget is causing this activity that sidebar is performing? And the answer to that is really requires us to go look at this type of file system and registry activity being performed by the sidebar. And I'm going to scroll through here, which is what I did when I originally troubleshot this just a couple weeks ago. And there's lots of file system and registry activity. And actually this might not be, well, so here we see accesses to the sample pictures directory. So that's obviously the picture previewer. That's a little slideshow gadget looking at through the sample pictures, which I haven't pointed at any other directory. Scanning through those. And it looks like I haven't caught it in this trace performing that CPU spike. I've just caught it switching the picture in that slideshow. But I've got a trace now. I've got a capture of sidebar during one of those big spikes that last several seconds. And let's go take a look and see if we can identify which gadget is causing that spike. So what we're going to see is a bunch of accesses to registry entries, but then we see occasional file system activity. And here's one, a read file from users, Mark Russ, app data, local Microsoft feeds, Robert Hensing's blog, feed.ms. And if we go scrolling through here, we're going to see lots of reads from those different locations. One of the ways that we could go and see which locations are being hit the most is use the basic data mining tools that are in the tool. So I'm going to go and say file summary, and this is going to scan through and show us which files were hit the most. And you can see up here in the first top few entries that there's a number of different paths that were accessed multiple thousands of times. And if we go scrolling over to the right to see which paths those are, they all have something in common. So which gadget do you think is causing that? Let's go back and take a look at the sidebar and see if we can figure it out. So which gadget do you think is causing it? It's the RSS gadget that's performing that activity. It's refreshing its feeds every 5 minutes, causing that CPU spike and associated file system and registry activity. So I troubleshot that. I actually went deeper and found out exactly why it was performing all these excessive operations, and I filed a bug with the sidebar team, with the gadget team. It's actually in the feed DLL, not the sidebar itself. But that's a case of troubleshooting that with Process Monitor and Process Explorer. So let's go ahead and actually exit that particular gadget so that we have a cleaned up system activity. So there's that gadget, I've gotten rid of it. And now the next thing I noticed when I was using this laptop over the last couple weeks is I saw activity in the system process. When I would go, and I'm not sure I'm going to see it here live, but as I scrolled around, I saw the system process spiking the CPU periodically. And there's a screenshot of what I actually saw. When I saw the spikes in the tray, I hovered the mouse, it said system process, I opened the system information dialog, and I saw a whole bunch of spikes. Hovering the mouse over any one of those peaks said it was the system process causing those spikes. Now what is the system process? It's a host process that is the home of device driver and operating system threads. It's not like a standard user mode process. And what I needed to do then was to look inside and see which thread was causing that activity, because that would be able to connect it with the operating system activity or the driver that was causing those spikes. So what is a thread and what is a process? That's a good time to clarify these concepts right here, because those of you that have just used Task Manager or not gone deep into Process Explorer might not have ever come across threads. A process is a container, and it hosts an application, and it also has an address space. It keeps track of resources that are opened by the application running inside that process, like synchronization, objects, files, register keys are all kept track of. Has a security profile, represents who's running that process. Whereas threads are actually what executes code. And a process will have at least one thread. Most processes have multiple threads these days. And each one of those threads can operate independently. It's the unit of scheduling in Windows. So the scheduler goes and schedules threads, not processes. And like I said, the system process is the home for these kernel mode and system threads. So what I needed to do, like I said, is go inside of the system process and look at the threads. And one of the ways that you can look inside a process and see its thread activity is with Process Explorer's Thread tab. And I'm going to go look inside the system process and look at its Threads tab. And the Threads tab comes up, shows you all the threads, and you can see threads running in different drivers. Like here are threads in the http.sys driver. Here's a thread in the iastore.sys driver. If you want to know what driver something is, you click on module. Like what is iastore? iastore is the Intel Matrix storage driver, manager driver. And then there's a whole bunch of generic operating system threads. So like here's event logger threads in the kernel. So I've got this sorted by CPU activity, actually here. And we may or may not see that kind of spike that I saw. I saw it earlier in this when I was in the speaker lounge, but we might not see it here. But when I saw one of those spikes, I looked at what was at the top consuming threads, and they were these threads right here. Here's a screenshot from just a couple days ago. They're generic worker threads. If you look at the name of those functions, they're worker threads. Now, how am I getting these names of the functions? Process Explorer relies on symbol information to show you names of functions within drivers or within images. And the symbol information is very easy to configure. You go to the options menu, you go to configure symbols, and you can see here how you would configure the symbols. First of all, what you need to do is download the debugging tools for Windows, that package that has WinDebug, the tool I introduced at the beginning. Then you need to point the debug help library line there at the dbg help DLL that's in the debugging tools for Windows. Point the symbol path at Microsoft's public symbol server. No need to memorize this. This is documented in the debugging tools for help web page and in the help file. And once you've got that, now you're going to get symbols for all of the Windows operating system components. And so that's how we can see that the functions within these drivers, like the NDIS driver, which is part of Windows, this NDIS periodic receive work queue thread. So the problem, though, that I was faced with here is that these threads that were consuming that CPU during those spikes are generic worker threads. And generic worker threads simply perform work on behalf of other drivers. Drivers feed them work to do. And so it wasn't clear which driver was really responsible for the spikes. They're hidden in these generic work processes. So I needed to look inside the system process to see what was going on, see what driver was causing those threads to execute. Really, those worker threads are calling functions within a driver, and I wanted to know which functions those were. So the tool I turned to was, instead of looking at stacks, which is something I'll show you a little bit later, how you can look at stacks of threads within Process Explorer. Unfortunately, I couldn't look at the stacks of these threads because they're in the system process, and on Vista, the system process is what's called a protected process. It's part of the DRM mechanisms, and so I couldn't actually look at the stacks. So I needed another tool to look inside and see what was going on there, and the tool I turned to is that tool, kern rate, that I mentioned. Now, kern rate is a tool that just uses built-in functionality in the kernel where a profiling interrupt goes off periodically, and then it samples wherever the current instruction pointer is on that processor. And then with this sample builds up buckets over time. When you exit the tool, when you Control-C out of it, it will dump out where it saw time being spent when it performed its samples. So it's really great for troubleshooting these kinds of spikes where you have enough samples that can show you meaningful information. It installs itself into the curview directory, and then you've got to go into the kern rates subdirectory, and then there's different versions of kern rate for different OSs. The one I'm going to use on Vista is this one, the XP one, and it's as easy to use as just pressing enter. What we're going to do is sample what's going on right now on this system. I'm not seeing any of those spikes, so it's not going to necessarily have the same results that I have in the screenshot on the slide. But another use for this is if you've ever had spikes in interrupts or DPCs. Interrupts or DPCs are interrupt-related processing, which in Task Manager shows up as idle time, but in Process Explorer shows up as two special pseudo processes right here, the interrupts and DPCs process. And if you see these guys consuming a lot of CPU, the question is which drivers are associated with those interrupts? Because that's really, some device is causing that interrupt activity, and looking at the driver would tell you which one to be concerned with. Unfortunately, there's no way to look inside and see a trace of what interrupts or DPC routines are firing. So a tool like kern rate, though, with its sampling, if there's lots of interrupt or DPC activity, will be good enough to show you what's going on. So I'm going to Control-C now, and there's a dump of the activity on this machine. In fact, the two top hits, so it sorts by the number of hits that it saw during its samples. The first one, well, no big surprise, is the kernel itself with the most hits, 12,016. But second place here is B7ND60X. So what is B57ND60X? And that is the exact same driver that I saw when I was troubleshooting those system spikes that you saw on the graph. So let's go see how we can figure out what BND60 whatever X is. And the way that we can do that is by opening the system information or the system process into DLL view. Now DLL view for any normal process would show you the DLLs that are mapped into that process. For the system process, it shows you the drivers that are loaded on the machine. I kind of arbitrarily just decided to associate the list of loaded drivers with the system process because that's where the driver threads live. And now let's go see what is B7ND60X.sys. Well, it's the Broadcom Net Extreme Gigabit Ethernet driver associated with the built-in NIC on this laptop. So I knew it was from Broadcom Corporation. And one of the first things I did was do an internet search to see if I had the most recent version. You can see the version is also displayed over here, 10.10. And so I did a search online here. And that's going to do a search with whatever search engine you've got configured. And this is what I came up with. And I saw references to versions of this driver with higher version numbers than what I've got. The driver that I've got is from February. But when I went to Dell's site, I couldn't find a newer version, and this is a Dell laptop. So I wasn't actually able to find a newer version that I could download and install on this machine. Instead, and I'm not even sure that whatever problem is causing those spikes is fixed in the newer versions. So I've reported this as a bug to Broadcom. But in any case, while I haven't really resolved the problem, I know what the problem is, and I can be on the lookout for a new update to this driver and get rid of it. And the fact of the matter is, it's not that big of a problem. I just noticed those heavy spikes in that one day, so I don't know what caused that activity. But with kern rate, I'd at least troubleshot the cause. Next, let's take a look at application hangs. And application hangs come in many different forms. A lot of times they'll come, you'll experience them where you go and open something, you perform some operation in the application, and boom, it freezes. And it might come back after a while, but it's like, what the heck was it doing when it went away? Or it might not ever come back ever. So what's going on? Now, this particular case I encountered in my own home. I had a machine where I was browsing through my folders in Explorer, and occasionally I'd come across a folder where Explorer would just hang for 30 seconds or 60 seconds before coming back, and then I was able to see the contents of the folder. This was on Windows XP. The Windows Explorer shell in Vista is a lot better about avoiding those kinds of hangs, but on Windows XP, Explorer was basically dead. How many people experienced that, hangs in Explorer? Yeah, so we all have. So what I did was ran FileMon, because this was before Process Monitor existed, and I got a trace of the activity. And the activity pointed at another machine on my network. You can see the references there are to / development C, a share on another machine, which I just, within the last week before I started encountering this problem, had taken offline. Now, the question was, why was my machine referencing, when I was going to these folders, this other machine that I'd decommissioned? So I turned to Regmon, the registry activity monitor, and captured a trace there. Now, you wouldn't need to use two different tools to troubleshoot this today. You could just use one tool, and that's Process Monitor. But what I saw was this query. What I did was search the output for / development, and I came across this line right there, a query value, HKey current classes root, PSP5, browser file default icon default, and you can see a reference to that other machine, actually executable on that other machine, psp.exe. And then it clicked. I was using a picture viewer called PaintShop Pro, and one of the nice things about PaintShop Pro is you don't actually have to install it. You can just run the exe. So what I'd done was put the exe on one machine on my network and then was running it from that machine on other machines to look at pictures. And then it had created an association on the other machines for certain file types pointing back at that original executable to show thumbnails, for example. And so when I came across one of those directories, Explorer said, oh, I need to go call this program to show the thumbnail, and then it would hang going out to the network. I actually can recreate this on Windows Vista. I've got a directory here. Let me fire up Process Monitor, make sure it's watching what's going on. And I'm going to browse to this directory, which is C demo. And there's a single file in there. When I right-click on it, notice that I get a donut. By the way, the donut is there to hypnotize you so you don't realize you're waiting. And then it finally comes back. Now, what's going on underneath the hood there? Let's go take a look at the Process Monitor trace, and I'm going to search right for the root cause, which is the same root cause as what we saw in that demo. And you can see Explorer right here doing a create file of another machine, Mr. Opteron, which is my machine at work, and getting back that bad network path. And this operation is the one that timed out. If we looked at the duration of this operation, it would be 30 seconds or so. So the question is, why is Mr. Opteron being referenced? And if we go back to the top and search for Mr. Opteron, actually these are HKey network remote path. That's not a good hit. So sometimes you've got to dig through and skip things that are false positives, false leads. But what we're going to come across, and it might have already cached this information. It actually already did. I've got a saved trace of this, because Explorer does what it does is cache information about file associations, actually. Oh, foobar is the one example here. And here's the answer. It's come across this file association, HKey classes root test.file.1 shell open command, and that points off, if we look at the value that came back, at that non-existent machine. So this was a trace I captured in another machine where I'd configured the same problem. And the way that I created this was by artificially creating a file association in the registry with test extension, which is what that test file has, and this non-existent machine to recreate that hang. Now, we've taken a look at some cases where looking at the thread and looking at the thread start address has answered the problem of what's causing CPU spike, for example. But sometimes we need to dig deeper and look at the thread stacks. And I made reference to thread stack a little bit earlier. What is a thread stack? It's a record for the thread of the functions that it's executed over time. And it's a way that the thread knows how to get back to the functions that it came from. Because programs are divided into functions, where one function will call on the services of another function. So you can see function 1 calling function 2 calling function 3. That's record of when we're in function 3, where we came from is stored in a per thread memory region called the thread stack. And things are pushed onto the stack and then popped off onto the stack. And you can look at the call stacks in Process Explorer by double clicking on a thread, and that will open the thread stack dialog, which will show you that history of functions which start where the thread is right now, working its way back. And a lot of times this can help you understand what's causing a problem. So I'm going to actually get Process Explorer ready here to look at that hanging thread doing that same right-click operation, because now I know that it's this browse UI thread from previously. Sometimes you've got to look at the stacks for a whole bunch of threads. And what we see is that thread is doing a path exeexist as part of that file association, calls kernel32 get file attributes, which calls into the kernel and then calls into the redirector driver, rbdss.sys. And I know this from experience, but if you saw a stack like this and suspected this was your root cause, you would go look, and redirector is the client side of file sharing. And you can see that it's waiting here for an answer to come back from that non-existent machine, which will eventually time out. Here's the wait right here. So that's looking at thread stacks. And here's a real world case where I use thread stacks to solve a problem again on my own home network. This is the previous version of Office, and previous versions of Office, all of the Office applications when you launch them go and automatically connect to all of your network printers that you've got configured for that machine. And they do it synchronously at startup. So one day I launch PowerPoint and it takes 60 seconds to launch before the window appears. So what I do is I relaunch PowerPoint, I open Process Explorer, I go to the PowerPoint executable, I go to the Threads tab, I double click on the single thread that existed at that point in this PowerPoint startup, and that's the stack that I saw. And actually I didn't know what the root cause was at the time, but this told me the answer. Winspool.drv is the printer, the client side of a printer communication. And you can see the RPC, that's a remote procedure call. So this was trying to do a communication with a network printer. In fact, this rang a bell for me because I'd just taken a printer offline a few days before. And so I had to go and remove it from the printer configuration for that machine. And then PowerPoint was able to start up instantly again. Error messages, though, are probably the most common type of problem that we troubleshoot. And I was using my system one day and got this error apparently out of the blue. And this is one of those ones that is kind of, you can't make this one up. Actually, you can. But this one isn't made up, unfortunately. An error has occurred while creating an error report. So I call this one the error message. And it's got an OK button. And I had no idea what had caused this. I'd been using my machine, done a bunch of things, and then this shows up. So the question is, who caused this dialog to show up? There's no identifying information on it. Task Manager can show you sometimes which windows are associated with which processes in the Applications tab. For top level windows, you can right click in Task Manager and say, take me to the process. It'll take you to the process list of the process owning that window. But for a dialog like this, it's really not a top level window, and so it won't show up in Task Manager's application list. So what I needed to use is a feature of Process Explorer, which is the window finder. And I'm going to show you the window finder in action on that window that I moved to the side so we can identify who popped up this window at the start of the presentation. So I'm going to take the window finder, drag it over this. You can see it select part of the window, any part, and there we go. The program that generated that is logonhelp.exe, the Windows NT Logon Helper application from Microsoft Corporation. So now I'm happy. I'm satisfied that this isn't really malware. It's something legitimate that's part of Windows, right? No, it's probably not. This is a trend in malware, which is to look like something legitimate. It's got a legitimate looking icon, a name that looks legitimate. It says it's from Microsoft, but it's really not. And just incidentally here, this is really is not directly part of troubleshooting here, but we can verify that it's from Microsoft or not by going here and saying verify on the image tab, and that will tell us unable to verify right here. If this had been a legitimate Microsoft executable, that would have said verified because the image would have been digitally signed and we would have been able to really confirm that it's from Microsoft. In this case, now we're suspicious that it's really not from Microsoft. But that's using the window finder in action. So let's go ahead and dismiss that. And in the case that I just showed you for that particular error dialog, I used the window finder and it took me to this process right here, pwconsole.exe, which is the Microsoft Office Live Meeting application, which I'd used and exited within a few minutes of that dialog box. So obviously, Live Meeting was shutting down and encountered an error. So I reported this as a bug to the Live Meeting team. Now this one, I mentioned that I ran into a problem on the plane on the way over. Now, long flight from the US, I ended up doing some work, and then I also want to play some games. And I've got a subscription to PC Gamer magazine in the US. It comes with a DVD that has a bunch of stuff on it, and I wanted to go see what was on the DVD. So let's go see what's on that DVD. Let me get Process Monitor ready to watch what's going on here. So I inserted the DVD, double-clicked. DVD is spinning up. And I'm all excited about the games that I'm going to end up playing on my great Vista laptop for games. And I get taken to this message which says, in order to view the video on this disk, you must have QuickTime 6.0 or higher installed. Please click the install button to the right to install QuickTime. You must relaunch this disk afterwards. So I said, oh, okay, well, I'm on the plane. I can't connect to the web and go download QuickTime directly from Apple, which is what I would have done. Instead, I was forced to press the Install QuickTime button, and this is what happened. It disappeared. So, of course, what do? You try it again, and it disappeared again. So then it was, okay, pull out Process Monitor and see what's going on. And what I did was scroll through the output, looking for something that might, from the exit of that process, working my way back, looking for something that might be related to what just happened. And what I ended up coming across was this. So LaunchDD is the program, and I ended up coming across references to qtinstall.exe, which probably stands for QuickTime Install, name not found. And these are queries of the DVD, which is drive letter D here. And you can see it's looking, kind of fishing its way around the DVD, looking for qtinstall or qtinstall link, and every time getting name not founds for those. So I went onto the DVD and I'd search the whole DVD for qtinstall or anything that might be a QuickTime installer, and it's not there. So there's a bug in the DVD. And I had to wait to get back to check into my hotel room. The first thing I did was run up to the room, download QuickTime, and then start playing games. So this one actually didn't happen to me, but happened to Dave Solomon's stepmother. Dave Solomon's my co-author in the Windows Internal series of books and also does troubleshooting presentations with me on occasion. And his mom calls him up one day and says, Dave, I'm trying to copy files to my USB key, and I get this error message. And actually, I'm going to reproduce this error message for you. So by sticking in my flash key, and I want you to notice something as I stick in this key, there's no auto start that shows up, which you normally expect when you stick in a USB key. It doesn't happen here. And this is the behavior that I see on all my machines at Microsoft. So what I'm going to do is come and navigate to that drive and copy some files onto it. A bunch of files. I'm going to copy and paste. Then I get this error message right here. Unexpected errors preventing the operation. Make a note of this error code. It might be useful. Some nice hex code, which is not useful. The directory or file cannot be created. And asked me to try again. Well, so Dave's stepmom, when she ran into this, tried again a bunch of times, and no luck. So she calls up Dave and says, Dave, I'm running into this problem, trying to copy files to this flash key. What do I do? So Dave says, well, okay, why don't you reformat the flash drive, or run check disk. It's the first thing he had her do. She ran check disk using the tools, no problem. So then he had her format it and retry the operation. She got the same error message. So now he's thinking that the USB flash drive is bad. So he has her go buy another flash drive. She buys the other flash drive, she sticks it in, does the same copy, gets the same error. So now he's thinking it's the USB controller on the machine. So he has her go buy a new laptop. No, she didn't. He has her try the operation on his stepdad and his dad's computer. And he gets the same error message. So now he's like, oh, maybe I should run process monitor and see what's going on. Which Dave violated his own slogan, which is when in doubt, run process monitor. Whenever you get something like this, run process monitor. See if you can see what's going on. So let's go see what's going on here. And I'm going to save us the time of having to scroll through the output, but well, actually, we don't have to. I'm going to search for tradbdo, which is the file that it encountered the error with in the output. And again, we're hitting false positives. Well, actually, these are from the original source of the copy. Really, we want tradbdo on the flash drive. So we're looking for references to it on the E drive when Explorer copies to it. And still more. You know what? I'm going to search for tradbdo. And here we go. And there's the create file with the cannot make error. And what is cannot make? So Dave calls me up and says, Mark, I get this cannot make error trying to copy these files to my mom's USB key. And I don't know what cannot make is either. So we do an internet search for cannot make, and we come across just a number of references to it, but really only one that really kind of describes what's going on. And that reference says, cannot make, status cannot make is an error message that comes out of the FAT file system driver, the FAT16 file system driver, when the root directory of the volume is full. And root directories on FAT volumes can hold at most 512 entries. Long file names occupy more than one entry, so that means in the root directory of a FAT volume, you can put at most 512 files, sometimes less if you've got long names. We counted the number of files in there and looked at the name lengths that Dave's stepmom was trying to copy, and sure enough, she'd basically filled up the root directory. So the workaround in this case, there's two workarounds. One is to format as FAT32, and the other one is to just create a subdirectory and copy the files into there. So with that solved, she was able to get on her way. This next example is one that I ran into when I was building Process Explorer itself. I ran into this error message that came out of the linker after I'd been finished debugging a previous instance of Process Explorer. And let me go ahead and recreate that error message for you. Again, get Process Monitor ready to watch what's going on. And what's going to pop out is that error message that says that it can't access the PDB file because it thinks the disk is full or there's a permissions problem. And here it is, link fatal error writing to program database, PDB, check for insufficient disk space. So of course the first thing I did was run process monitor, and then I'm going to search for procexp.pdb and find out what error is really underlying the one. Now there's some false positives, it's doing queries. By the way, this fast I/O disallowed, that is simply just the file system telling the I/O system to come the slow path instead of the fast path. It's not really an error. But here I came across this, now real error, trying to create procexp.pdb, a sharing violation coming from the Microsoft program database, which is part of the build process. So sharing violation means that somebody else has this file open, and what I did at that point was go use the handle view in Process Explorer. Basically search for open handles to that file. And so that bears talking a little bit about the handle view. The handle view, again, is the list of resources that a process has open. If we go look at the handles, for example, in Explorer, you can see it's got synchronization events open, it's got files open, it's got registry keys open a little bit further down. In the case of a sharing violation, that means somebody's got a handle to that file open. And the way that you can quickly identify who's got that handle open is to use the file search, enter something that is a unique identifier for that file that you're looking for, and then type search. Now, who's got this file open? It's WinDebug itself. And here's the handle that it's got open in the WinDebug handle table. Which instance of WinDebug? It's this one right here. It's because I was debugging Process Explorer, and the debugger holds that PDB file open when it's debugging it, so when I tried to build, ran into that collision. And so when I actually ran into that problem, it turned out that it was a bug in the debugger where it didn't let go of the PDB even after I'd exited the debug session. And that was fixed in the next release of the debugger. This one is a mysterious logon error message that one of Dave's friends got. Whenever they logged onto the machine, they would get this: the drive is not ready for use, the door may be open, please check the drive. Drive may be closed. So at this point, he's wondering, where the door is on the hard disk that he can close it. He used Process Explorer to try to find out which process had caused this message, and this being a generic system error message was associated with CSRSS, the Win32 subsystem process. So no good answer there. So what he turned to was looking for the root cause of the message, and he ran FileMon at the time in the system account so that he could watch the logon process. Now that command right there, psexec, that's a sysinternals tool. If you run it with those switches, SID, and specify an application, that application will be run in the system account. When you log off, it won't be terminated. When you log back on, it will reappear on the desktop, having, in the case of Process Monitor, captured the log off and subsequent log on. So he did that with FileMon and then looked at the trace and saw qttask.exe doing an invalid device request to a network drive that he'd deleted, the Z drive. And it turned out that he'd been watching a QuickTime video off that drive before he deleted it. qttask, which is the QuickTime startup helper, had remembered that and was going and looking for it. So a solution here was to disable qttask, which I recommend everybody does. There's not because I don't like Apple, but all these applications want to help you by slowing down your boot process or your login process. They all put in helper applications, which actually don't help. They actually hurt. So the way to disable those kinds of applications is with auto runs. You could use msconfig, but auto runs, which is a sysinternals tool, shows you a lot more information about a lot more locations. And you can see a scan of my system here. I've got a whole bunch of auto starts. The Everything tab shows me everything, and then different tabs show you subcategories of the different auto starts, including the name of the image and who made it. One of the ways that you can weed through the cruft is to say verified code signatures and include and hide signed Microsoft utilities. Now this will show you only stuff that's not signed by Microsoft, which most of the stuff that we're interested in tracking down and getting rid of is not from Microsoft. Like here's Adobe Speed Launcher, which is one of those things that slows you down instead of helping you. So I'm going to delete it right there and actually get access denied on Vista. I have to run as administrator, but that's the first thing you know that I'm going to do after this session is go delete it. The logon helper application that we saw pop up, here it is, Windows NT logon helper application. Auto runs tells us says it's from Microsoft, but it's not verified. And again, this is one of those locations that doesn't show up in msconfig, this current version policies explorer run. So one of the things that I always do, just as basic troubleshooting, is just get rid of all the cruft in the auto start locations. Now speaking of auto, well another kind of auto is the autoplay. And you remember I stuck in this key and I didn't get any autoplay experience? Well the reason, what I did when I ran into this, because I wanted to autoplay for the Vista session yesterday morning so that I could show you how when you stick in one of these things, Vista says, hey, do you want to use this for Ready Boost? I wasn't getting the pop-up, and I was like, how am I going to make this demo work? So I went to the autoplay settings on my machine, and everything looked fine. You can see all the defaults are there. So I should have been getting the auto run experience according to this. So what I did was capture the trace of the insertion with auto runs, and I've got that trace saved. Right here. And I searched for autoplay and auto runs, and I'm going to save the trouble of digging through here and take us right to the root cause, which is, you can see that there's some not founds, but then we come across this Explorer reg query value to HKey local machine software, Microsoft Windows current version policies Explorer no drive type auto run, and if we look at what value came back, it's 255. We can actually jump into the registry from right here to take a look at that, and there's no drive type auto run with 255. I did a web search, and I came across a knowledge base article that said no drive type auto run, this group policy setting specifies a mask of which types of devices won't have auto run experience, where FF means no auto run at all. So obviously group policy settings within Microsoft prevent auto run on all devices. So my fix for this was this, but that fix isn't good enough, right? Because the next time group policy comes down, it's going to be set back, and I didn't want that to happen. Being the local admin on the machine, I can take things into my own hand. And you know where I'm going with this. So now group policy is not going to be messing with my auto run setting anymore. All right, unknown images. So we've come across that long on helper application as one example of an unknown image, which I'll show you how to dig in a little bit more and see if we can find anything really identifying about it. But on my own machine one day, as I was doing my normal auto run kind of scan of the machine to see if there was any junk there, I ran across this program, which made my heart stop actually for a few seconds. IE check. No description, no company name, and it's sitting in the Windows directory. All classic signs of malware. Malware that isn't sophisticated enough to pretend it's something, but has an image name, if you looked at Task Manager, that makes it look real and is sitting in a Windows system location. So I was really concerned that I'd somehow picked up on an infection. So now I needed to figure out what IE check was. Well, I did a search online, and you can do that right from auto runs, and I didn't come across any hits on IE check. So now I needed to take things into my own hands. And the way that I did that was to look inside of IE check to see if there was anything identifying in there. The tool that I used to do that is the strings utility. It's also from sysinternals, and what that will do is look inside of an image and dump out any printable strings. And the way that I do this typically is I run strings and then I pipe that output to a file and then open that file and scan through it. In this case, when I did that, I came across these settings right here. Icon edit 2 and this in particular, WinApps Planet icon edit 2. And I immediately knew what this was associated with because I'd gone looking for an icon editor that could edit large 256 by 256 icons, Vista style icons, which isn't supported with Visual Studio 2005 at the time. And so I came across this freeware utility, icon editor version 2, installed it, and it had ended up dropping this thing into my auto start location. So now I knew what it was associated with and I got rid of it. And I contacted the author and I said, what is this? And he said, this is associated with his DRM, basically his anti-copy technology. And I recommended that he identify himself a little bit clearer so that other people wouldn't have heart attacks when they came across it like this. And hopefully he's done so. I haven't followed up on that. All right, our final topic, blue screens and hangs. So why does Windows crash? And this is our fast 15-minute introduction to the hang and crash dump analysis with some real-world examples here. But first, why does it even crash in the first place? Wouldn't it be nicer if it just pretended like nothing happened and continued on? Well, the reason that it crashes is because kernel mode components, drivers and the operating system itself, are executing with total privilege and can access any memory on the machine, including buffers that are coming from applications and buffers that are going to disks and the system cache. If one of those components performs an illegal operation, the system has to assume that that user data, the stuff you really care about, has become corrupt, or might be about to become corrupt, because we can't trust this driver anymore. The system implicitly trusts them when it loads them, but once it sees them performing some bad operation, it has to say, wait a minute, I don't trust you anymore. You could be messing with data here. And the only recourse it has is to crash the machine, stop it as quickly as possible. And so that's why it'll crash. And some of the illegal operations that drivers can perform include accessing invalid memory, accessing memory at an interrupt request level that is too high, because it's only allowed, pageable memory accesses are only allowed at certain low-level interrupt levels. And not causing a resource deadlock, obviously. We don't want the machine to hang. When you have a crash, you know that when you reboot, Windows asks you if you want to send that information to Microsoft, and will actually go take you to the online crash analysis website, where it will provide you helpful information about the crash. Unfortunately, many times, the information it gives you is this. How many people have seen that if you've gone to the online crash analysis website? So, well, I guess you could call that helpful. I guess you could say that's slightly more helpful than saying your machine crashed, but really that's not helping me at all know why. You know, I'd really like to know what driver is causing my machine to crash so I could go fix that driver and get rid of it. So how many people have done crash dump analysis before? See, raise your hand. So a few of you have taken a stab at it. A lot of you probably haven't, because you didn't realize just how amazingly easy it is to do basic crash dump analysis. Now, you need a few things to get set up to do crash dump analysis. One is the WinDebug tool. It comes in the debugging tools package. When you get WinDebug installed, let me go ahead and exit that instance of WinDebug and launch a new one. You need to go to the symbol file path and configure symbols. Again, pointed at the Microsoft public symbol server, so you get all the images, symbols for the Microsoft Windows images. The kernel is the most important one. Because I'm on an unpredictable network here, I'm going to get rid of the reference here to the path, and what this is just going to rely on is my local cache of symbols that I've got here on this machine. And so let's take a look at some real-world examples where I had to do crash dump analysis to troubleshoot what was going on my machine. So in this particular case, I was experiencing an intermediate hard hang. And I'm going to show you how to deal with hard hangs here. I asked how many people had had blue screens or hangs. Let's break it down. How many people have had a hard hang before on Windows? And the troubleshooting technique you probably used is just pressing the reset button. It's actually, there is a way in most cases to troubleshoot hard hangs, and that requires some pre-preparation, going into the registry and setting that registry key right there. HK local machine, system, current control set, services, I8042 port, parameters, crash on control scroll, and set that to 1. That's documented in the debugging tools help file. If you encounter a hard hang after setting that registry value and rebooting, you can type a magic keystroke sequence, right control, scroll lock, holding down the right control, and you will get a crash. And let's go see that in action on my Windows XP machine, which I've configured ahead of time. So I'm going to type right control, scroll lock, and there's something really kind of fulfilling about doing that, causing a blue screen like that. And what this is doing is saving a crash dump file out, which then, after the reboot, we could go take a look at. Now, I'm not going to take a look at that one. But let's come back and take a look at one that I actually encountered. Because one day, and by the way, every time I set up a machine for the first time, that's one of the first things I do is go set that registry value. Just in case I have a hard hang, I'm ready to go and try to troubleshoot it. Well, in this particular case, I'd had this hard hang, and I went and I opened the dump file after I'd gotten the hard hang. And by the way, if you do send one of those crashes into Microsoft, you know what it tells you? It says, user manually initiated crash dump file, or crash dump, which is a bit like going to the doctor and the doctor saying, well, don't do that. Because it's telling us that it knows that we crashed the machine ourselves. So the thing you've got to do when you analyze one of these dumps, and I'm going to skip this junk, it's telling us we've got symbol misconfiguration. This is from an old system that I don't have access to the symbols for anymore. But what I'm going to do is just type the KB command, which is the stack command. And this shows us what the thread on the CPU that crashed the machine was doing, or what the CPU that crashed the machine was doing at the time I crashed, I typed control scroll lock. So let's take a look at and break down what we're seeing here. Now these NTs right here. So I see an NT frame, and this is like the stack that we saw earlier. I see an NT right here, and I see an NT right here. That is the NTOS kernel. That is the operating system kernel. Typically not very useful in the cases of troubleshooting a crash or a hang. If we look close to the bottom of the stack, and the way we read this is that I8242 port called NT kernel. I8042 port should seem familiar because that's the registry value that we set a parameter for. That is the keyboard class driver. So that driver, when it recognized the control scroll lock keystroke sequence, called into the kernel saying crash the machine, and that explains those frames right there. Now the frames that we haven't looked at yet are these right here. And this particular frame, that's the NDISC library. So this is the network helper library for network adapter drivers, which leaves only two frames of interest here, the YK51X86 frames. One of the ways that you can try to quickly look to see what one of these drivers is, and unfortunately that information isn't in this dump, is to use this command lmkvm, which is in the slide, and this might sometimes show you image file information for that driver if it happens to be still in RAM at the time of the crash. Now in this case it's not in RAM, so what I needed to do was then go to identify that driver, go to the system process and Process Explorer and look at the DLL view, or another way is just to go to the drivers directory, Windows System 32 drivers, and look at the properties on that particular driver. It turns out that that driver is a network adapter driver, and one of the ways that you can see which version you've got is either using that file version that shows up in that properties, or looking at this timestamp here. And what I always do when I run across something like this, go to the vendor's website, see if I've got the latest version, and if I don't, fix it. In this particular case, I didn't have the latest version of this wireless driver, downloaded it, installed it, and I didn't have any more hangs after that. Here's another case, and this one was really super exciting. This was such an exciting afternoon of troubleshooting for me that I actually had to take a nap after I was done. I was so exhausted from the thrill of the chase on this one. So this one, I had this home machine, and periodically it would hard hang. It was once every few weeks it would just hard hang. It was the shared family computer. And I'd made the mistake of not configuring it to do the crash on control scroll lock thing. So one afternoon it hard hangs, and my wife's really annoyed with me in Windows and Microsoft. So I go and reboot the machine, and I configure crash on control scroll lock. Of course, I'm going to reboot the machine now so that that setting kicks in, so the next hard hang I get, I can troubleshoot. I reboot the machine, and lo and behold, during the boot process, I get a crash, which I hadn't experienced on that machine before. So I went and opened that crash up. I'm going to exit this one. And do an bang analyze -v, which is what you want to do when you get a crash, is to go ahead and click on this link right there. It says use bang analyze -v to get detailed debugging information. Always do that. And then look at the stack trace that it shows you here. Now we already know that NT, well, probably not the problem. Anybody recognize this driver? I'm not going to embarrass the vendor, but they do make audio cards, well known for them. And what I did was the lmkv command on that driver, lmkvm, to see what version of that driver I had. And notice that I had a really, really old version on this machine, probably from when I bought the machine from the OEM. So I went to this audio vendor's website, and they release a new driver like every 2 weeks. So I downloaded the latest driver and then rebooted the machine, because after installing the driver I had to reboot the machine. Well, to my excitement, to my just utter thrill, after I rebooted the machine, it hung. So what I was originally after happened right away. So immediately I said, well, I can control scroll lock it. So I crashed the machine and I go load the dump file. And this is what I came across. Now this is a multiprocessor machine. Again, bang analyze-v won't show us anything about a manually initiated crash. It'll just say, hey, you crashed the machine. What you need to do when you get a hang again is to do the kb command. And so I did kb and looked at what I had here. And again, we could ignore these few frames right here because they are the kernel or the i8042 port driver calling the kernel to crash the machine. Really what we're interested in are these frames right here. Well, in this, remember I told you that that's the network helper adapter library. Well, that clues us in that this has something to do with a network driver, and WPN111, that is the wireless USB adapter driver that I'd had installed on this machine. From another well-known company in the area of network appliances, network gear you might say. I'm not going to tell you the name of the company though. And this being a multiprocessor machine, I wanted to make sure that both CPUs, I understood what was going on in both CPUs, because that's what the CPU that crashed the machine was doing. But if you notice, I've got a little 0 down there in the bottom corner. That tells me that I'm looking at processor 0 on this multiprocessor machine. To switch context to processor 1, you type tilde1 and then do the same command. And this is what was going on the other processor. The same driver, calling KE acquire spin lock. So it was obvious what was happening here is there was a deadlock within this driver on this multiprocessor, taking up both CPUs, spinning them, and hanging the system hard. And again, did LMKV, looked at the version of that driver, went to this company's website, saw that they had a more recent version, downloaded it, installed it, and now that machine hasn't crashed ever since this troubleshooting example. So case closed on that one. Again, very exciting afternoon. Slept for the next 24 hours. So that brings us to the end of our session. Wanted to hope what came across was that with just a few little tools and a few minutes, you can translate most what apparently unsolvable problems, whether it be sluggish performance, some bizarre error message, a crash, or a hang, into something that you can actually understand and maybe even solve by going and making sure that you've got the latest version of an application or addressing the root cause. At least I really actually feel better knowing what the problem is rather than not knowing, even if there's nothing I can do about it. Like in the case of this Broadcom driver that's causing those spikes, at least I know what's causing those spikes when I do get them, and I can be on the lookout for a new version. If you want more detailed information, kind of in this vein, Windows Internals 4th edition, the operating system book I co-authored with Dave Solomon. If you want that, a great place to learn how the operating system works, how threads work, how the processes work, how device drivers work, how the kernel works. The sysinternals video library, this is an interactive DVD tutorial that I put together with Dave Solomon before the Microsoft acquisition, which you can get through Dave's site, solsem.com. And then last year at IT Forum, I delivered a talk on just using Process Monitor, and it was just a few weeks after the initial release of Process Monitor. That webcast is available on the Spotlight IT website, and you can get to it from the sysinternals Mark's webcast links. I want to ask, I collect these things. Like I told you, I've got literally close to 50 of these troubleshooting examples. I was only able to show you basically a highlight reel of them. If you run in across a troubleshooting example that you solve, please capture screenshots, log files, any other information that is in the same vein of what I've been showing you here, and send it to me. And if you send it to me, I'll send you back a signed copy of the current edition of Windows Internals, either the 4th edition or the 5th edition if it comes out. Also, if you really enjoyed the session and you want to hear it again, I'm giving it again this afternoon at 3:15. How many people are leaving before 3:15, just out of curiosity? Okay, well, you're out of luck then. So hopefully this is useful and interesting, informative, and your troubleshooting experiences will go smoother. Your systems will run better. Thank you very much.